Hello, everybody. My name is Ignacio Castillo. I am from Mexico, from the University of Mexico City. And my colleagues are from this university and from the Universidad Politécnica Salesiana. In this occasion, I will show the paper 016. The name of the paper is The Pacific Wave Advanced Network Backbone, an Emulation Approach under IPv6. Well, I'm very happy to be here at the Third International Conference on Power Electronics and Computer Applications. Well, let's see. In this occasion, we will check advanced networks. After, we will show briefly the methodology, results, and conclusions. At first, we have to think about advanced networks. What does it mean? Well, when we think about Internet, one, or the commercial Internet, we are talking about three levels: the backbone level, the distribution level, and the access level, which reaches to the common people, or common business. Well, so what are advanced networks? Advanced networks are very well related to the national research and education networks. It means Internet 2 for each country, but also talking about continents. We could have a kind of associations or corporations which interconnect their advanced networks. Well, in this case, we try to understand the Internet 1 using the knowledge that we have in Internet 2. Why? Because Internet service provider companies are companies which try to maintain in high secrecy the infrastructure topology of their networks because they are the owners. That happens for Internet 1 or the commercial Internet. But what can be public? The Internet 2 topology. Obviously, the backbone topology. Not completely all the details, which reaches the national research and education networks. But in this case, we have to consider that the most important part is the backbone, but also the distribution. So in this case, there is a fusion between the access layer and the distribution layer, because there is not too much people. It means only research centers, universities, and some companies doing research. So we are interested in checking the transition between the use of IPv4 to IPv6. Well, in this occasion, we can see that advanced networks began really after the internet boom in 1995, after the commercial boom, and then the advanced networks must be developed to make tests. So this is where the IPv6 were developed, and MPLS and other technologies. Where in this case we are watching the backbone for the infrastructure related to the optical fiber, which corresponds to Internet 2, and specifically it's parallel to the Internet 1. So we can see, for example, for Russia, the RUNET, for China, CERNET, ERNET, or for example, in United States, the advanced network take the name of Internet 2. For Europe, the Gigabit, the European Advanced Network, GENT, for Canada, Canary, for the Asia Pacific Advanced Networks, which join together the advanced networks for Asia, countries in Asia, for example, and for the advanced networks in Latin America, the name is CLARA, the Consortium for Latin America and Advanced Networks. For the case of Africa, we have the Africa Connect, and well, specifically, I will put this kind of example in the case of CERNET for China, the China Education and Research Network. It means only Internet 2. We are seeing the backbone infrastructure And well, to be brief, the idea to make the transition, the complete transition from IPv4 to IPv6 in all the backbone infrastructure is to be completed till 2030. So for each country, or even for each continent, we have this kind of advanced networks. So specifically, what we are looking for in this paper? Well, we are looking for the study of the connectivity and management of the backbone topology for the Pacific Wave Network, which interconnects 29 countries. In this case, we are moving all the emulation using IPv6 protocols. In this case, we can find, for example, what we say Taiwan, Hong Kong, Hawaii, Australia, CUDI for Mexico, DRAN, USA, the main interconnection points, using the Seattle Pacific Wave, China, Korea, Singapore, and all the 29 countries. Where, in this case, we use a total of 45 backbone routers. And why are we using emulation? Well, in real world, the ISP, the Internet Service Provider companies, are the owners of this kind of technology. This infrastructure is very expensive. We can see, for example, two Cisco equipments at the left and Juniper at the right. $1 million, $5 million, or even $10 million, or even more when it's completely configured and with all the optical fiber systems. Well, when a university or research center use the commercial internet, they pay for the service and the infrastructure for internet, for the commercial internet, not what everybody calls internet. You pay for that to the internet service provider company. But also, specifically, if you wish internet to, this is not commercial. This is only for universities and research centers. So what you have to do is to pay for the service and for the infrastructure. But who's the owner? The owner is the internet service provider company. So in many countries, there are only one service provider for internet too, or even in other countries, only two companies. So meanwhile, for the internet one, could be 10 or even 100 companies in a specific country. So, because this is very expensive, specifically for making studies about the backbone infrastructure, we use simulation. Then, in this case, we use GNS3, but also, for example, VMware for virtual machine, but it could be another tool. We also use Wireshark, iReasoning, VMware, and other tools. Specifically for this case, we are in the methodology part. What we are using is to reproduce inside the GNS3 the topology using the 45 backbone routers. In this case, the Cisco 7200 in GNS3, and configuring it for connectivity and management. Let's check details. Well, at the left, we see the configuration using IPv6 protocols, in this case, interfaces, and using OpenShortest Path First version 3. And at the right side, we are configuring the Border Gateway Protocol number 4 for the corresponding interfaces and working everything. So, for the management, in this case, we have to remember that we need agents, also the network management system, and the MIB. It means the management information base. Well, in this case, we have to activate the SNMP server, the Simple Network Management Protocol version 3, using the security keys, and also enable traps. Well, what about results? Well, when we were testing connectivity, we tried to check not only ping and trace route from one router to another, from one extreme to another. We also sent files, text files, video files, but also streaming. So due to the complexity, the time it spent, the transition or transference for information, it was very close to reality. But let's check the figure at the right. We are also checking packets, IPv6 packets, using Wireshark. Well, the details are in the paper. But for the management test, we also see details capture of packets, SNMP B3 packets captured by Wireshark, but also we try to test with 5 variables: sysname, the number of interfaces, table of interfaces, the address interfaces, but also the routing table. Um, uh, and, and we see in this figure at the right some elements when we checked in real the protocol, the SNMP protocol, the operation get or bulk. We use bulk when we try to take tables, the response, and well. So in this case, we have the interfaces, the number of interfaces in a specific router, but also the detail shown in a table. Well, to end, what kind of conclusions we had? Well, we study a real backbone infrastructure for the Pacific Wave network by emulation using IPv6 protocols and BGP4. Okay, this is used in order to collect evidence for GNS3 development group and improving characteristics. We use it an i7 processor, and the emulation took 70% of the RAM and 42 of the CPU resources. So although even latency took 10 milliseconds and everything seems to be okay, and the size of the files and the complexity of the topology were moving great between one autonomous system to another, because we're taking one router for each country, for example, we have 2 kind of limitations. One is the backbone equipments that GNS3 has, but also the limitation of the backbone bandwidth. It means it uses only 1 gigabit per second, when in real life we have 100, for example, gigabit per second. So this information will be very useful for the development group in GNS3, and we study real backbone infrastructure. Well, thank you very much for your interest, and more details are at the paper. Thank you very much again.